All right, section 5.4, adding and subtracting radical expressions. All right, so we want to add or subtract each radical expression. In order to do this, the index, meaning like square root, cube root, fourth root, so on and so forth, and the radicand, meaning the number underneath the radical, need to be the same. So it's just like combining like terms. You would combine the 4 plus 3, so this equals 7 square root of 2. So you keep your radical part the same. All right, part B, 2 square root of 3 minus 5 square root of 3. Again, we have like terms, so just combine the integers. 2 minus 5 is negative 3. So negative 3 square root of 3. All right, part C, we have 3 square root of 24 plus the square root of 54. As you can see with this one, the indices are the same, but the radicands are not. So we want to break down those square roots first. So we're going to look for the largest perfect square within 24, and that's going to be 4. So I can write that as 4 times 6. And the largest perfect square within 54, that'll be 9 times 6. So now I have 3 times 2, because the square root of 4 is 2. So 3 times 2 square root of 6 plus 3 square root of 6. And then I'll multiply here. So that's 6 square root of 6 plus 3 square root of 6. Now I have like terms, and that equals 9 square root of 6. All right, same with this one. We want to break down those square roots first. So I can rewrite this as 4 times 5x minus the square root of 9 times 5x. The square root of 4 is 2, so now that's 2 times 2 square root of 5x minus 3 square root of 5x. 2 times 2 is 4, so 4 square root of 5x minus 3 square root of 5x equals 1 square root of 5x, or you can just write square root of 5x. All right, 2 square root of 3 minus 4 square root of 5. There's no way for you to break those radicals down, and they are not like terms, so this expression cannot be simplified further. All right. Example 2. Same thing. Here we just have a cube root instead of a square root. So the first thing you want to do is break it down into a perfect cube. So I can rewrite this as 2 cube root of 8 times 2. 8 is going to be that perfect cube within 16 minus 5 times the cube root of 27 times 2. 27 is that perfect cube. All right, so now we'll take the cube root of 8, and that is 2. So now it's 2 times 2, cube root of 2, minus 5 times the cube root of 27 is 3. So 5 times 3, cube root of 2. All right, simplify that by multiplying. So now we have 4 cube root of 2 minus 15 cube root of 2. We have like terms. 4 minus 15, that's going to be a negative 11 cube root of 2. All right, so the next one is 2 cube root of x squared y plus the cube root of 8 x to the 5th, y to the 4th. All right, I want to rewrite everything in terms of a perfect cube. Now this first one, there are no perfect cubes, so it's going to stay the same. 2 cube root of x squared y. All right, 8 is already a perfect cube, so I'll leave that. X to the 5th, I'll rewrite that as x cubed times x squared. And y to the 4th, I'll rewrite that as y cubed times y. All right, let's break down that second radical. And, oh, sorry, it's supposed to be a plus. The cube root of 8 is 2. And then I can pull out an x and a y. And that leaves the cube root of x squared y. So the cube root of x cubed, I pulled that out as x. And the cube root of y cubed, I pulled that out as y. And then the x squared and the y are left under the radical. All right, so now I don't have like terms. I can't combine, but I can factor out. So I can pull out that 2 plus 2xy, and that will leave the cube root of x squared y. All right, 5 times the square root of 4x cubed plus 3 cube root of 64x to the 4th. All right, so we have a different index here, but let's first break it down and then see what we can do from there. So that'll be 5 square root of 4x squared x. I'm just rewriting it in terms of a perfect square. Plus 3 cube root of, what is the perfect cube within 64? It's 4. Okay, so we'll leave that. So I'll write this as 64x cubed x. All right, so now taking that square root, that's going to be 5 times 2x square root of x. And what I did was I pulled out here a 2x, and then that x is left underneath the radical. Plus 3 times the cube root of 64 is 4. So 3 times 4x. And that leaves the cube root of x. Okay. So now let's multiply, and that will be 10x square root of x plus 12x cube root of x. And that's pretty much all I can do since I have a different index for each term. All right, and then the last example says perform the indicated operations. Again, you want to break down each term as much as possible and then see what you can do from there. So I'm going to rewrite everything in terms of perfect squares. So that's going to be 2 times, let's see, I'm going to go ahead and separate these terms here. All right, so this will be 25 times 3 over the square root of 16 is already a perfect square. I'm going to rewrite 8 as 4 times 2, and then the square root of 32 as 16 times 2. All right, so now I have 2 times 5 square root of 3 over 4. So it's 2 times that term there. And then 4 times 2 square root of 2 over 4 square root of 2. All right, now I would look and see what you can possibly cancel out. So The 2 and the 4 we can cancel or reduce that, and that'll leave a 2 there. Here I can reduce the 4 with the 4, and the square root of 2's will cancel out, and that would just leave 2. So now I have 5 square root of 3 over 2 plus 2. All right, the very last step is you want to write this as a single quotient, meaning you want this to be one whole fraction. So I'll just say rewrite as a single quotient. All right, so find the LCD. I can write this as 2 over 1, meaning the LCD is 2. So I'll multiply this fraction by 2 over 2. So now I have 5 square root of 3 plus 4, and all of this is over 2, and that would be the final answer. All right, let's try another one. 10 times the cube root of 5 over x to the 6 minus 3 times the cube root of 4 over x to the 9th. All right, so first I'm going to separate this. I'll make this 10 times the cube root of 5 over x to the 2nd, because the cube root of x to the 6 is x to the 2nd, minus 3 times the cube root of 4 over x to the 3rd. It's supposed to be to the 3rd, because the cube root of x to the 9th is x to the 3rd. All right, so I'll just write it this way. 10 cube root of 5 over x squared minus 3 cube root of 4 over x cubed. And I want to write it as a single quotient. Okay, so the LCD would be x cubed. So that means I would need to multiply this term by x. So now I have 10x cube root of 5 minus 3 cube root of 4, and all of this is over x cubed, and that is the final answer.